or view factor, all mean the same. It's very important concept in radiation, shape factor concept. Questions were repeatedly asked regarding this in the earlier gate examinations. How do you define a shape factor? For example, if I consider two surfaces which are exchanging heat by radiation, this is surface 1, this is surface 2. If I suppose if there are 100 units of energy are leaving the surface 1, out of which 70 units reach, I suppose 100 units of energy leaving the surface 1, 70 units reach surface 2, then shape factor of 1 with respect to 2 is 70 by 100.7. F12 is equal to fraction of radiation energy leaving surface 1 which reaches surface 2. In this case, how many units are reaching surface 2? 70. How many units are leaving surface 1? 100. So here in this case 0.7. So in general, shape factor of Mn I can define as fraction of radiation energy leaving surface M which reaches surface N. Similarly, F21 is fraction of radiation energy leaving surface 2 which reaches surface 1. Shape factor purely depends on the how two bodies are oriented with respect to each other, how the two bodies are looking at each other. Based on that particular point only shape factor is defined. Shape factor is independent of the temperatures, is independent of the nature of the surface, etc. It is purely a geometry factor or a configuration factor. It depends on how two bodies are placed with respect to each other. Suppose if a surface or a body is completely surrounded by another surface, then the surface of the inner body with respect to outer body is 1. For example, if a body is completely surrounded by another surface or body, then shape factor of inner surface with respect to outer is a unity. For example, I have taken a small body. It is completely surrounded by outer surface. This is inner, this is outer. 1, 2. F12 is equal to 1. shape factor of the inner surface with respect to the outer is 1 if inner surface is completely surrounded by outer one. Another example is a circular plate is there, considered as a surface 1. It is surrounded by a hollow hemisphere of the same radius. This circular plate is enclosed by a hollow hemisphere. In such case, F12 is equal to 1. Now I shall deal with some of the relations among the shape factors or between the shape factors. Relations between shape factors. First and foremost important relation is reciprocity relation or reciprocal relation. If we are dealing with two surfaces of areas A1 and A2 exchanging heat by radiation, then A1 F12 is equal to A2 F21. This is very useful relation because if we know one shape factor, we could easily calculate the other shape factor by knowing the areas of the surfaces. This is very useful relation. Number 2, second one. Suppose that the shape factor for radiation from A3 to the combined area A12 is desired or to be calculated as shown in the figure. This is A3, this is combined area A1, A2, combined area is A1, 2. Then F3, shape factor of 3 with respect to the combined area is equal to F31 plus F32. That is, total shape factor is the sum of its parts. Now we could multiply A3 in both sides. A3 F3122 is equal to A3 F31 plus A3 F32. And from reciprocity relation, A3 F3122 combined is equal to A1, 2 F122 to 3, and A3 F31 is equal to A1 F13, and A3 F32 is equal to A2 F2 to 3. Therefore, the expression could be rewritten as, hence A1 A122 F122 comma dash 3 is equal to A1 F123 plus A2 F223, which states that total radiation arriving at 3 is the sum of the radiations from surfaces 1 to 2. Total radiation arriving at surface 3 is the sum of the radiations from surfaces 1 and 2. Now, I take another relation. If there are n number of surfaces involved in a radiation heat exchange problem, then F11 plus F12 plus F13 etc. F1n is equal to 1. Similarly, F21 plus F22 plus F23 etc. F2n is equal to 1. Like that, we can write for n surfaces Fn1 plus Fn2 etc. Fnn is equal to 1. Fourth relation, for a flat surface F11 is equal to 0 because nothing is intercepted by the surface. No part of the energy leaving the surface 1 shall be intercepted by the same surface. Similarly, for a convex surface also, this is the convex surface. If you take this as surface 1, no energy leaving 1 will be intercepted by the surface 1. Here also F11 is 0. But for concave surface or a curved surface like this is the surface 1, inner side. So some of the energy leaving 1 shall be intercepted by the same surface. Here F11 is not equal to 0, F11 is greater than 0 because some of the energy leaving the concave surface may be intercepted by the same surface. Hence, F11 is greater than 0. But for the flat surface and for the convex surface, F11 is 0 because there can't be any self-interception of energy by the same surface. Now I shall do a small objective problem given in GATE 2001. Objective question. For the circular tube of equal length and diameter shown below, the view factor F13 is 0.17. The view factor F122 in this case will be this surface is A1, this is A2, this is A3, this is D. Answers are A 0.17, B 0.21, C 0.79, D 0.83. What is the shape factor of F1 to 2? 2 is the concave surface, curved concave surfaces. Therefore, it will have self-interception, whereas A1 and A3 surfaces are flat surfaces. There can't be any self-interception. F13 has been given. Since A1 is equal to A3 implies F13 is equal to F31. F11 plus F12 plus F13 is equal to 1, because there are three surfaces involved in the radiation heat exchange problem, A1, A2 and A3. Because 1 is a flat surface, F11 is 0. Therefore, F13 is equal to 0.17 given implies F12 is equal to 1 minus F13. That is 1 minus 0.17, that is 0.73. Answer is 0.83. I am sorry, 0.83. Answer is D. 0.83 is the answer. Here L is equal to D, that is also given. Now I would like to extend the problem. For example, I would like to calculate F22, because concave surface is how much? I would like to calculate what is F22. Now I can write the similar relation, F22 plus F21 plus F23 is equal to 1. Now let us calculate F21 and F23. From symmetry of problem or figure, we can know that in this figure, if this is surface 2, this is 1, this is 3, F21 will be equal to the F23. That is symmetry, from the similarity of the figure, or from symmetry of the figure. But how to calculate F21? We have already calculated F12. F12 is calculated as 0.83. A1 F12 is equal to A2 F21. That is from reciprocity relation. Therefore, F21 is equal to F23 is equal to A1 by A2 into F12. What is A1? Pi by 4 D square. What is A2? Pi D L. L is D in the figure, it is given. L is equal to D into F12 is 0.83. Therefore, you will get D square gets cancelled, pi gets cancelled, it is 1 by 4 into 0.83. Therefore, F22 is equal to 1 minus 2 into F21. Therefore, 1 minus 2 into 1 by 4 into 0.83. That is 1 minus 0.83 by 2. This is the answer for F22. That is shape factor of the surface 2 with respect to itself. With respect to itself. Now I shall do a problem given in GATE 2005. The following figure was generated from experimental data relating spectral black body emissive power relating spectral black body emissive power relating spectral black body emissive power to wavelength at three temperatures T1, T2 and T3. T1 greater than T2 greater than T3. The figure is given like this. The experimental data were represented graphically. This is T1, T2, T3. This is lambda, watts per meter square micrometer. The conclusion is that the measurements are A, correct because the maxima in EB lambda show the correct trend. B, correct because Planck's law is satisfied. C, wrong because Stephen Boltzmann law is not satisfied. Wrong because Wein's displacement law is not satisfied. The answer is D, because according to Wein's displacement law, if T1 is greater than T2 greater than T3, the peak of the curves should go left side, should get displaced left side to the shorter wavelengths. In fact, in the figure, they are almost at the same length. In fact, rather T3 is at a smaller wavelength. This is wrong. So, according to Wein's displacement law, if the wavelength at the peak of T1 is less than wavelength at peak of T2 is less than the wavelength at the peak of T3, then Wein's displacement law would be satisfied. But the figure is not like that. So, answer is D. Next, I shall do another problem regarding the shape factors. An enclosure consists of four surfaces 1, 2, 3 and 4. The view factors for radiation, heat transfer, where the subscripts 1, 2, 3, 4 refer to the respective surfaces are F11 is equal to 0.1, F12 is equal to 0.4 and F13 is equal to 0.25. The surface areas of A1 and A4 are 4 meter square and 2 meter square respectively. The view factor F41 is A 0.75, B 0.50, C 0.25, D 0.10. From relations of shape factors, I can say that F11 plus F12 plus F13 plus F14 is equal to 1. Implies F14 is equal to 1 minus F11 plus F12 plus F13. That is 1 minus 0.1 plus 0.4 plus 0.25. It comes to 0.25 F14. From reciprocity relation, A1 F14 is equal to A4 F41. Therefore, F421 is A1 by A4 into F14. Therefore, A1 is given as 4, A4 is given as 2, F14 is 0.25. That is, answer is 0.5 B. Now I shall give another problem on matching. Matching. The list one is given as type of radiation. List 2 is given as characteristic. In the list 1, A is black body, B grey body, C specular body, D diffuse. Right side 1, emissivity does not depend on wavelength. 2, mirror like reflection. 3, zero reflectivity. 4, intensity same in all directions. Now, if you look at the left and right, the black body is a zero reflectivity. It does not reflect anything. A is for answers or A for 3. B, grey body. It is a body whose monochromatic emissivity is independent of wavelength. Therefore, for B, answer is 1. Specular body. What do you mean by specular body? If the incident radiation follows the mirror law, mirror-like reflection. If the incident radiation angle theta, this is equal to pi. Incident ray of radiation, it is leaving like this. That is mirror-like reflection. It is called specular body. C is matched with 2. And diffuse. Diffuse means this is specular. What is diffuse? The incident radiation is uniformly reflected in all the directions. This is called as diffusive nature of the body. This is called diffuse. A diffuse body is the one whose intensity of radiation is same in all directions. I is not a function of theta. This is called diffuse body. In a diffuse body, intensity of radiation shall be the same in all the directions. That is the definition of diffuse body.